Okay, in this video, we're going to finish looking at Chapter 1 of our textbook. Okay, in this slide, there is a lot going on, but mainly this is about why we have seasons. Why is there a summer and a winter, a spring and a fall? So the couple of definitions here. The ecliptic is the plane of the Earth's path around the sun. All the planets move around the sun in one flat plane. And so the ecliptic is a plane of the Earth's path around the sun, and it's at about a 23.5-degree angle to the celestial equator. The celestial equator is, if you imagine the equator around the Earth, but not being around the Earth, but being around the celestial sphere that we talked about in the previous video, that is what is meant by the celestial equator. And basically, all of this means is that the Earth's axis of rotation is tilted relative to the plane of the Earth's orbit. It's not perpendicular like you might expect, but it's actually tilted at this 23.5-degree angle. Now, the northernmost point of the path above the celestial equator is called the summer solstice. The southernmost is called the winter solstice. Points where the path crosses the celestial equator are the vernal and autumnal equinoxes. So these are basically the official definitions of the solstices and the equinoxes, but really that doesn't help anybody understand what they mean. So I don't want you to be able to know these definitions. I want you to be able to tell me, what does it mean if we talk about a solstice or an equinox? But before I try to explain what all this means, let's look at this picture, because there is a huge amount of information going on in this picture. Now, this obviously is a picture of the Earth revolving around the sun, and we see 4 different locations of the Earth at different times of the year. Now, the Earth is rotating around an axis that's tilted relative to the ecliptic. And so this motion around the sun is all in one plane, and the axis of the Earth's spin is tilted relative, so it's not straight up and down, it's not perpendicular to the plane, it's tilted at an angle. And so when the Earth is on this side of the sun, because of the Earth's tilt, you can see the northern hemisphere is tilted towards the sun, and the southern hemisphere is tilted away from the sun. Now the Earth goes around its orbit, and when the Earth is on the opposite side of the sun, you can see the north is now tilted away from the sun, and the south is tilted towards the sun. And that is a very important thing. Now, halfway between those two, here we can see that the Earth is neither tilted away or towards the sun. It's kind of in a neutral position. And that is going to be very important. Now this point of the Earth in its orbit is drawn at what's called the summer solstice. And that occurs on June 21st. And if you're in the northern hemisphere, that is the longest day of the year. But if you're in the southern hemisphere, which is pointed away from the sun, that is the shortest day of the year. And so that is the summer solstice. And you guys might remember that when it is summer in the northern hemisphere, it's actually winter in the southern hemisphere. You may have learned that in grade school. If not, that's true. So when it is summer here, it is winter in Australia, and vice versa. Now over on the other side, we have the winter solstice, and in the northern hemisphere, that works out to be the shortest day of the year. And of course, in the southern hemisphere, it would be the longest day of the year for people living in the southern hemisphere. Now, when it's the summer solstice, that being the longest day of the year, that means the northern hemisphere is getting more sunlight than the southern hemisphere. More in the sense that it's longer. It's the northern hemisphere is illuminated many more hours than the southern hemisphere. Because the day is longer in the northern hemisphere, it gets more sunlight. And that's part of the reason why summer is hotter than winter, because you're getting more hours of sunlight during the day. But there's also another very important reason why summers are hotter than winter. Not only are you getting more hours of sunlight during the day, the sunlight is actually concentrated. And so you can see in the picture here, there's this little square, and it's blown up. And the idea is you've got rays of light coming from the sun, and these rays of light are basically uniform coming from the sun. But because the Earth's northern hemisphere is tilted towards the sun, that sunlight gets bunched up and it's concentrated. Whereas over here, the northern hemisphere is pointed away from the sun. If I look at my little box and blow it up, I'm tilted away from the sun, so the sunlight is getting spread out and it's less concentrated. So it's a double whammy. In the summer, you're getting longer hours of sunlight and the sunlight is more concentrated. So that's why we have a summer. And of course, when the Earth is on the opposite side of the sun, the northern hemisphere is pointed away from the sun, and so the days are shorter and the sunlight is less concentrated. And so that's why you have a winter. Now, basically, if I ask you on a test to tell me what is the summer solstice and what is the winter solstice, if you just understand that the summer solstice is the longest day of the year and the winter solstice is the shortest day of the year, I'm going to be happy with that. That's basically what I want you to get. Now, what are these guys, the equinoxes? Well, here, this would be the longest day of the year. If the Earth was over here somewhere, the days would start getting shorter and shorter and shorter and shorter until the Earth reaches this position here, which is called the vernal equinox, which is on March 21. Now, when you're at the vernal equinox, basically what that means is the amount of sunlight that the northern hemisphere gets is equal to the amount of sunlight that the southern hemisphere gets. And so basically the day and night are the same amount of time. And then once you cross the vernal equinox, the nights are actually longer than the days. You're actually getting less sunlight than you are during the day. So at the equinox, you would be getting 12 hours of sunlight. Over here, you would be getting less than 12 hours of sunlight. Over here, you'd be getting more than 12 hours of sunlight. And again, that's all if you were in the northern hemisphere. Everything is reversed if you're in the southern hemisphere. It's important to remember that. So when it's summer in the northern hemisphere, it's actually winter in the southern hemisphere, and vice versa. So again, recapping the important points. And again, we're gonna take it for the northern hemisphere. Everything's reversed for the southern hemisphere. When you're at the summer solstice, that's the longest day of the year. The sunlight is more concentrated when you're in summer, and the days are longer. The days start getting shorter until you get to the vernal equinox, when you have an equal amount of sunlight in the day and the night. And then after you come over here, because the axis is now tilting away from the sun, the nights are getting longer and you have less sunlight during the day. And that happens until the winter solstice, which is the shortest day of the year. Now, one of the things that's interesting, we talked in the previous slide about how the Earth's axis of rotation was fixed as the Earth goes around the sun. And so in part of the year, that means the northern hemisphere is pointed towards the sun, and the opposite part of the year, it's pointed away from the sun. But that axis itself is actually slowly rotating, and it in fact traces a cone. And this process is called precession, or simply precession. Precession is a rotation of the Earth's axis itself. And this is a very common test question for me. I very often will ask this: what is precession? And it is the rotation of the Earth's axis itself. The most common wrong answer I get, and I hate to give you a wrong answer, but I point this out so hopefully you won't do it. People think that precession just means that the Earth is rotating around its own axis. But that's not the point. The point is that the axis about which the Earth is rotating is itself rotating, and in fact, it traces out a cone. And this process takes 26,000 years to complete one circle. Now, what's the effect of this? So, 26,000 years is how long it takes to go through the complete cone. That means that in 13,000 years, or half of that, the Earth's axis is going to be pointing in that direction. It would be basically on the opposite side. The effect of that means that basically you will see different constellations in the night sky because the way that the Earth is oriented has changed. We see different constellations in the summer than we see in the winter, and that will be reversed in 13,000 years. So the constellations we normally see in the winter months now, in 13,000 years, would be seen in the summer months, and vice versa. Here we have a slide showing how the moon exhibits different phases. And so the idea is this. So these yellow arrows are the sunlight coming from the sun, which is over on the left somewhere. And basically, if I just pick a couple of these, you can see why we see different phases of the moon. The moon is actually revolving around the Earth, and it takes about 30 days for the moon to go all the way around the Earth. In fact, it's 29 and a half days to go through the whole cycle of phases. Now, I'm sure you've all looked up at the moon and you've learned that the moon has different phases. This picture is showing you why that's the case. And so if I look at the moon in different points of its orbit, this side, the side that's on the left in the picture of the moon, is always the side that is illuminated by the sun. Now, if you're on the Earth and the sun is over here on the left, if you're standing right here, you would be directly underneath the sun and it would be noon. Now, if you're on the opposite side of the Earth, it would be midnight and you wouldn't even be able to see the sun because it's on the opposite side of the Earth. Now, at different points of the month, the moon is going to be in these different positions relative to you. So imagine that you're standing on the Earth on the midnight side right here. And if the moon is on the opposite side of the Earth, you cannot see through the Earth and you can't see the moon at all. That's called a new moon, and that's when you can't even see the moon at all. So if you go out at night and you look up and you can't find the moon at all, that is when the moon is at its new moon phase, and it's on the opposite side of the Earth relative to you, so you can't see it. Now, when the moon is right here, this side of the moon is the one that's illuminated by the sun, and if you're standing right here, you would see the moon as fully illuminated. You would see the entire disk of the moon, and that's what we call a full moon. Now, if you are standing here and you see the moon here, you're not going to see the full illumination of the moon because you're looking at it at an angle, and all you're going to see is a sliver that is illuminated. And so at different points, based on where the moon is, you can only see a portion of the moon being lit up. So if you're standing here and the moon is here in the night sky, you can only see the half of the moon that's illuminated by the sun. And as you look at different angles, you can only see less and less until it's at the new moon position. So that's why the moon has different phases. It's because of the way that the sun illuminates the moon and how the angles are to where you are between the sun and the moon. Okay. Here we want to look at eclipses. Now, there are actually two different kinds of eclipses. There's what's called a solar eclipse and what's called a lunar eclipse. And eclipses basically occur when one object casts a shadow on another object. In particular, we're talking about the Earth and the moon. And so up above, we can see here, if the moon is here, the moon shadow is not going to land on the Earth, and so the moon shadow will pass by. And if the moon is over here, the Earth shadow is going to pass by, and it's not going to land on the moon. So there would be no eclipse in either of these situations because there's no shadow falling on one thing or another thing. But in the lower part of the picture, we see two different kinds of eclipses. So over on the left is the sun. The sunlight's coming in from the left to the right. If the moon is on this side of the Earth, the moon's shadow will fall on the Earth. Now, this is what most people think of as an eclipse. This is what's called a solar eclipse, and this is when the moon's shadow falls on the Earth. And you may want to pause the video and write this down. So this is the moon shadow. It's falling on the Earth. So if you were on the Earth right here, this is on the ocean right now, but if you were on a boat right here and the moon shadow passes over you, basically it would blot out the sun and it would grow dark. And that's what we call a solar eclipse. Now, if the moon is on the other side of the Earth, and so here's the sunlight coming in so that the Earth is in front of the moon, the Earth's shadow will fall on the moon. And that is called a lunar eclipse. And that is basically the difference. Now, some of the sunlight gets past the Earth and lights on the moon. So that's why the moon doesn't completely disappear. But what you do see is that the shadow of the Earth falls on the moon. And that will make the moon appear darker. And it also will give the moon kind of a colored reddish tint. Some of the sunlight is actually passing through the atmosphere. And as it passes through the atmosphere, it kind of bends and falls on the moon. And the sunlight passing through the long portion of the Earth's atmosphere causes the light to take on a reddish tint. We'll talk about why that is later. But basically, you guys know that sunsets are very often red and orange. That's because the sunlight is going through a longer path through the atmosphere. And this is why you can see sort of a reddish tint on the moon. So if you ever go outside and look up and you see the moon and the moon is glowing kind of red or orange, that's actually because the moon is in a lunar eclipse. Now, you could imagine that if the moon were right here, only part of the moon would be in the Earth's shadow, and so that would be a less striking lunar eclipse. But if the moon is completely in the Earth's shadow as it is there, you can see there's a little inset picture here that you can see just how red the moon can appear. Now, this picture is a little confusing, but I'm going to try to explain it because it's showing kind of an important idea. Now, we've talked previously in a previous video that the Earth moves around the sun in a path that is in a plane. The Earth has a moon that is orbiting it. It is also orbiting in a plane, but they're not in the same plane. So you can see here the plane of the moon's orbit is tilted relative to the plane of the Earth's orbit. So the moon's orbit around the Earth is tilted relative to the Earth's orbit around the sun. And because of that, we don't get the moon and the Earth lining up every month. And so eclipses don't occur every month. They occur much less frequently than that. And very often, in terms of the solar eclipses, as was in one of the previous slides, they often occur out over the ocean. So even when they do occur, you don't get to see them. But every once in a while, they occur over land. And if you ever get a chance to view one, I highly recommend it. It's a really breathtaking sight. Now, it may also be worth noting, though, that when you're talking about solar eclipses, that sometimes the moon is not in the right position to entirely block out the sun. But when it is, that's called a total solar eclipse. And if it's not in the right position to completely block out the sun, it's called a partial solar eclipse. Sometimes it's called an annular solar eclipse, depending on what part of the sunlight is getting blocked out or not. But just mainly the idea I want you to understand is that there are eclipses like most people think of eclipses where the sun is completely blotted out. There are eclipses where the moon is only partially blocking the sun. That's called a partial eclipse. And then there are lunar eclipses where the moon is having the Earth's shadow cast upon it, which is different than the moon casting its shadow on the Earth. And so understanding the distinction between a lunar solar eclipse and a solar eclipse is very important. And it's one of the things that I want you to take away from this slide, from this presentation. So it will definitely be a question on the test. So often promise that I'm going to ask this question or that question, but I definitely expect you to be able to explain the difference between a lunar eclipse, which is the eclipse where the Earth's shadow falls on the moon, and a solar eclipse where the moon shadow falls on the Earth.